Welcome to our next series on titration. Please, I want to watch you to subscribe to our channel. Also click on the bell so that we can notify you. You can be notified when we have uploaded a new video. Thank you. So today we have another question here. Let us study it together. To determine water of crystallization. That is our task. Our task is to determine water of crystallization. You are provided with solution P10 and P14 solutions. So B10 is hydrated sodium carbonate. That is the formula, chemical formula, prepared by dissolving 9.536 grams of hydrated sodium carbonate in water and making it to 500 centimeters cube. Then P14 is 0.1667 capital M molar HCl. Good. So we have a base and an acid. This is a neutralization reaction which is taking place. So we want to look at it. Our procedure. Place 25 centimeters cube of solution B10 in a beaker. We use a conical flask. So I think yes, should be a conical flask. Add 2 to 3 drops of indicator. Place solution P10, P14 in a purette and titrate against the P10 solution until the pink color just disappear. So our table is fully filled up. As you can see, this time round I have used 2 decimal places. And I have maintained everywhere using 2 decimal places. So if you decided to use 2 decimal places, ensure you maintain the 2 decimal places. If you use 1 decimal place, please ensure you maintain that 1 decimal place because it has a mark. So let us see the average, our average. This is the average. Our average. That is 19.90 plus 20.10 plus 20.00 and then divide by everything by 3. This one will give us 60.00 divided by 3, which gives us 20.00 centimeters cube. We want to maintain the decimal point. Calculate the number of moles of P14 used. So we want to calculate the number of moles of solution P14 that was used. So we have to go back to what we were provided so that we can study and see what we were given. So you are provided with so what is P14? P14, first you must make sure you understand what is P14. P14 ukiangalia ni HCl, so it is HCl. Aya, what was the morality of that solution? Tumepewa ni 0.167 capital M. Capital M represents morality. So what it means that 0.167 capital M implies this, means that 0.1667 is the number of moles which are contained in 1,000 centimeters cube of solution B14. That's what it means. But P14 tulitumia kiasi gani? We used P14 only 20. Therefore, so if This is the number of moles in 1,000. What will be the number of moles in 20? Because P14 we used 14. P14 we used 20, sorry. So we ask 20 centimeters cube of B14. We have how many moles? Because that's what we are looking for. So it is 20 times 0.1667 divided by 1,000. This will give us 0.0003334 moles. Right. Let us go to next question. Write the equation for the reaction. So before you write the equation, you should know what is reacting. B14 is hydrochloric acid and the P10 is sodium carbonate. So that one is a reaction between a carbonate and an acid. Therefore, you should know the products. So let us write the equation. That is sodium HCl, which will give us sodium chloride plus CO2 plus water. Water is a liquid. This one is a gas, and this one is aqueous solution. This one is aqueous, and this one, because it is a solution, therefore it is aqueous. So the next thing is to balance the equation. Let us balance. We can see sodium here, we have 2 atoms. Here we must put 2 here that we can. So chloride atoms here, there are 2. We put 2 here to balance. Right, we have finished that. We have a mark. This one should be 1 mark. There's no way that one can. This is 1 mark. Next, calculate the number of moles of sodium carbonate. Sodium carbonate. Remember, sodium carbonate is B10. You should know. This one is B10 and this one is B14. We already have number of moles of B14. So the number of moles here is 0.00334. This one. We have this. Like you can see, but you can see the number, the ratio is 1 to 2, meaning the moles of sodium carbonate is going to be a half the number of moles of the HCl, a half of it, because the ratio here is 1, here is 2. So that one is simple. Remember, this one is 25 centimeters cube, which reacted with 20 centimeters cube P14. So since the mole ratio with the carbonate HCl is 2 to 1, moles of sodium carbonate is equal to a half times 0.00334, which will give us 0.00167 moles. So this is the number of moles in 25 centimeters cube sodium carbonate. Next question. Calculate the molarity of sodium carbonate solution. Calculate the molarity of sodium carbonate solution. Molarity. I will not get hard to remind you that molarity is the number of moles in 1 liter. Molarity is the number of moles in 1 liter. So now we know the number of moles of sodium carbonate solution B10 in 25. We know that, what we have done from the other side. So we are going to ask if 25 centimeters cube of sodium carbonate contains 0.001667 moles. This one here, because we know the number of moles in 25 of sodium carbonate, that is the number of moles, this one. So if this one is in 25, what will be the number of moles in 1,000 centimeters cube of sodium carbonate? Molarity is the number of moles in 1,000 in 1 liter. This times this divided by this will give you 0.06668, capital M. Capital M stands for molarity. F, calculate the number of moles in 500 centimeters cube solution of sodium carbonate. Number of moles in 500. But we know the number of moles in 1,000. So if we know the number of moles in 1,000, it is easier for us to know the number of moles in 500. It is a half actually. So let us see whether it is going to be a half. It is supposed to be a half number of moles of this. If 1,000 is this, what about 500? 1,000 centimeters cube of sodium carbonate solution B10 iko na moles ngapi? 0.06668. 500 centimeters cube will contain what? This times this divided by this. This one will give you 0.0334 moles. Or I can give you the formula. There is a triangle we have here. Molarity, volume in liters, that is V in liters, and then moles. So we are asked to calculate moles of 500. So we have volume, and we know the molarity of this. Molarity of the carbonate is this. So we can now use the formula. Moles equal to molarity times volume in liters. This volume must be in liters. Our molarity is 0.0668 times volume. The volume is 500. But the 500 is in centimeters, so we convert it to a liter by dividing by this. So this times this, the answer is going to be the same. Okay, the next one is calculated the RFM of the hydrated sodium. Calculated the, this one is supposed to hydrate sodium carbonate. Sodium carbonate. So calculate the RFM. There is this formula, this triangle here. Molarity, mass in grams per liter. Grams per liter is RFM. RFM is mass in grams per liter divided by molarity. If I want molarity and I have mass in grams per liter, I can get. But now, what we have is the mass of sodium carbonate in 500. You come back. here. Look here, that this carbonate was prepared by dissolving 9.536 in 500. So that is not the mass in grams per liter, that is the mass in 500. So we can get the mass in 1 liter. So that is the first task. So we say that 500 centimeters cube was prepared by using the mass, which was 9.536 grams. So 1,000, which is a liter. What will be the mass? So it is this times this divided by this, which is 1,000 times 9.536, 500. This one goes here once, and it will give you 19.072 grams per liter. Now we have the mass in grams per liter, which is required by the formula. So if we have this one, and then we have the molarity of the carbonate, then it is simple. Now, the formula says that RFM is equal to mass in grams per liter of the carbonate divided by molarity of the carbonate. Molarity of the carbonate. This one is 19.072. That is the mass. And then the molarity is here of the carbonate. Remember, the molarity of the carbonate is here. 0.06668. Use your calculator and you have to get 286.0 grams. And this is the RFM. And that is the RFM. The last question says, determine the value of X in the salt there. What is missing here is that sodium equal to 23, carbon equal to 12, hydrogen is equal to 1. What else? Oxygen is equal to 16. That is what is missing. So, sodium, hydrated, X water. The air, when you add everything here, it gives you RFM. And that RFM is this RFM, which is equal to 286 grams. So we want to add and then get the value of X. Remember, this is a dot. This X you multiply it with everything here. So sodium, moja ni 23. One of them is 23, but there are two of them, times 2. Plus, carbon is 1, that is 12. Oxygen, 1 atom is 16, there are 3 atoms. And then plus X times 16 plus 2, which is 18. So it is good to put X here because 18 times X, it is 18X. So we will have 18X. Will give us 286. So this, it is 46 plus, this is 48 plus 60. Yeah, 48 plus 12 is 60, yes. Plus 18X will give us 286. So let us add it. If you add it plus this one will give us 106 plus 18x equal to 286. So like terms together, this one will go to this side, it will cross equal signs and it becomes negative. So 18x equal to 286 minus 106. 18x will equal to 180. So you divide it by 18 to get the value of X. Divide it by 18 to get the value of X. X equal to 10. So the correct formula for the carbonate is sodium to CO3 dot 10 water of crystallization. Thank you. I want to urge you to subscribe, click on the notification, kindly like, comment, and we are very thankful for you to watch. You have watched, thank you, and I know you have learned something. Thank you.